Welcome to the online lecture series of refrigeration and air conditioning. Here is Professor Lakshman Mane. This is a video session on bypass factor of cooling and heating coil. In this session, you will be able to explain bypass factor of cooling coil and heating coil. You will also be able to explain efficiency of coil. Here we will take sensible cooling concept. In this case, variable temperature of entering air is reduced. That is from temperature TD1 to TD2 without changing its specific humidity. So in this case, specific humidity W1 is equal to W2. So here amount of air at a temperature TD1 is entering, passing over the coil which is having temperature TD3, and air is coming out at a temperature TD2. Refrigerant is a medium of cooling to the air which is passing through this coil. So here the temperature of the air coming out of the apparatus, that is TD2, will be more than the surface temperature of the cooling coil, means TD3. Now this happens because bypass process of air, that is the unaffected air to the coil, happens. Now this is measured in terms of a factor which is called as bypass factor. Here in this diagram we can see 1 kilogram of air is going inside with a temperature TD1. This air is passing over this coil. The coil temperature, surface temperature is TD3. Now this air is coming out, that is 1 kilogram at a temperature TD2. So inside this air has two parts. This air is divided into two parts. X kg of air is bypassing the coil, means it is not coming in a contact of coil, that is the unaffected air, and 1 minus x kilogram of air that comes in a direct contact with the coil which is having temperature TD3. This is affected air. So here will be an enthalpy balance. Enthalpy of outlet air is equal to enthalpy of bypass air plus enthalpy of air coming in a contact of coil, means M2H2 is equal to M1H1 plus M3H3. 2 is outlet, 1 is inlet, and 3 is coil. In terms of temperature, 1 kilogram outlet air into CPM into variable temperature TD2 is equal to entering air X kg, this is bypass air, into CPM into TD1, its temperature, minus contacted air 1 minus x kg CPM into coil temperature TD3, where CPM is specific humid heat of air. Simplifying this equation, 1 into CPM into TD2 is equal to x CPM TD1 plus CPM TD3 minus x CPM TD3. CPM is same on all sides of the equation, so cancellation of CPM term. We find equation TD2 is equal to x TD1 plus TD3 minus x TD3. Separation of the terms, TD2 minus TD3 is equal to x TD1 minus x TD3. Taking x common, this is equation x into TD1 minus TD3, other side TD2 minus TD3. By arranging the terms, we find x is equal to TD2 minus TD3 divided by TD1 minus TD3, where x is called as bypass factor of coil. So bypass factor of cooling coil we have already derived. This can be written in this way: air outlet temperature TD2 minus coil surface temperature TD3 divided by air inlet temperature TD1 minus coil surface temperature TD3. For understanding in a simple way, we can have general formula: bypass factor for cooling coil is equal to difference of ratio of opposite side difference to total difference. This process is 1 to 3, so opposite side is 2, 3. So opposite side difference means 2 minus 3 divided by total difference means 1 minus 3. Difference always take in higher temperature minus lower temperature. Now the concept is next, that is 1 minus bypass factor, which is called as contact factor, or it is also called as efficiency of coil. So efficiency of cooling coil will be equal to 1 minus bypass factor. So 1 minus bypass factor formula. Simplifying this, we find efficiency of cooling coil as a TD1 minus TD2 divided by TD1 minus TD3. So 1 minus 2, this effective change in a temperature, divided by 1 minus 3 means total change in a temperature. Similarly, we can have bypass factor of heating coil. Here the air is passed over the heating coil. Heating medium is used here as a steam. So air inside 1, air outside 2. So in this case, the temperature of the air coming out means TD2. This will be less than the surface temperature of the coil TD3. Now this happens because of bypassing of the air. So here bypass factor of heating coil we can write by the general formula, that is opposite side difference divided by total difference. The process is 1, 2, 3. So opposite side difference is this 2, 3, which can be written as 3 minus 2 means TD3 minus TD2 divided by total difference means difference between point number 3 and 1. So TD3 minus TD1. Efficiency of heating coil means 1 minus bypass factor, that is also called as contact factor. So 1 minus bypass factor formula. Simplifying this equation, efficiency of heating coil will get TD2 minus TD1 divided by TD3 minus TD1. So at the end of this session, you can explain bypass factor of cooling coil and heating coil. You can also explain efficiency of coil. If you like this video, please subscribe and share. Thank you.